Okay, so I thought that I would give you an overview of what we're working on here in the lab. And I'll just invite you into our laboratory here where we have experiments ongoing, and we have several microscopes here that I can show you. And here we are taking single cardiac muscle cells, and we look at their function on the microscope. And we're especially interested in how calcium moves around the cell, because calcium is what causes the heart muscle cells to contract. So we know that calcium is disrupted in heart failure, and that in a heart failure patient, all of the muscle cells that make the heart contract, they contract more poorly, more slowly, more weakly. So your heart, you get less power out of your heartbeat. And we know that changes in calcium homeostasis are at least in part responsible for this. So if we look here at some of the pictures which we have on our microscope, we can see that we look at cell structures which look like this. And there are these tubes which run through the cell, and they're very well organized in a healthy cell. And you can see that if we compare with a cell from a heart failure individual, we can see that the T-tubules are disrupted. So we know that we have disrupted structure in these cells, and to understand how this affects calcium homeostasis in the cell, I can show you this movie which looks at calcium being released across the cell. And we know that this affects the contraction and the relaxation of the cell. So here you can see the situation in a normal cell, and you see that when the cell is electrically stimulated, a normal cell has release of calcium all the way along the cell, very powerful release of calcium. This gives you a very strong contraction of the cell, strong contraction of the whole heart. And if we compare that situation with what happens in heart failure, we can see that the situation here is a bit different. You see that calcium goes up slowly and unevenly across the cell. This is related to the changes in the structure that I showed you, changes in the tubules. And this slower, more uneven rise of calcium gives you a weaker contraction of the cell, a weaker contraction of the whole heart. So this is what we're focused on in this laboratory, understanding the ways that calcium is changed, understanding how this gives you a weaker contraction of the heart. And our hope is that we can reverse these changes and treat heart failure patients.